Today I'm going to talk about, and I will teach you about the product design and product inside of the CATIA software. So let's see. Okay, today's topic is product assembly using CATIA. So before that, we just know about little bit about the software part, and the today's content is what is assembly, how we can create the assembly using CATIA software, what will be the approaching, and what will be the benefits for using the assembly and the kinds of assembly, uh, and how to create in CATIA software. So there are two kinds of assembly, top down assembly and the bottom up assembly. Top down assembly and the bottom up assembly. And now see. So first of all, assembly is a together of more than one components, and not, we can't say together more than one components, we can't say that one is assembly. Together more than one components together with in appropriate manner, made together, made to each other, then we can say that profile, and that part and that total whole component is our assembly component that you can say as a product. And assembly, here the assembly is required to check the parameters of the parts assembly. So mm, if the components are attached together, made together, then we can easily recognize the shape and the size of the profile, so that we can get the required product. Approaching is that likewise the constraint, sketch constraint is required to for the assembly, so that sketch constraint and some dimensioning and some constraint that to maintain the shape size of the profile, that is very important whether we are creating our profile. Before going to assembly, we have to make some profile. So before make some profile, we have to make some sketch. And for the sketch, constraint is important. The constraint is important to maintain the exact shape size of the freedom. And the constraint means to restricting the degrees of freedom, all the degrees of freedom, all sides of degrees of freedom we have to restrict. Then we can uh, complete and we can get the required sketch and product, whatever you can say. And then next will be the if we are going to software part, and how to open the assembly workbench inside the CATIA software. This is the process. First of all, just remember this one, I will show you in the software part. So this will be the process. We first of all we have to go the start menu, mechanical design, and then we are going to assembly design. Inside the assembly design, this component and this toolbar features inside the features is very important. Product structure toolbar, constraint, and the move toolbar. And inside the move toolbars and move constraint product structure tools, and these features are available, and more than one features are available inside each of the tools. We will see how to use them. Okay, now, and the thing is, why should we use the assembly? Why should we use the assembly? What is the requirement is that this one, first one is a customizably of orders. That
Hello, ma'am.
customizably
Excuse
of
me.
orders. Yes.
Ma'am, slide is
Yes.
not visible. Actually, first page is
Only first
this
page,
front
only
panel.
first page is visible. Only first page.
Okay,
The
just a
PowerPoint
minute.
page is only visible, madam.
Now it's visible.
No.
No, no.
No, ma'am.
Just a
No,
minute. Just is it visible?
Yes, ma'am.
Yes.
yes, ma'am.
Now it's visible.
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes, ma'am.
This one.
Yes,
Yes.
ma'am.
Yes, yes, ma'am.
Okay. Oh, okay. Sorry for the inconvenience. Okay. Okay. Now I'll just repeating the same thing. The content today's content is, first of all we should know about some little bit theory part, then I'll jump into our the software part. Okay, so first of all, what is assembly, the requirement of the assembly, what will be the benefits of the assembly, and the kinds of assembly. We should know about the kinds of assembly. And inside the software we will see the top down assembly and the bottom of assembly. Okay, now it's visible my next
Yes, ma'am. Visual.
okay,
Yes, ma'am.
thank you. Okay, thank you. So now assembly. The assembly is required to check the parameters of the parts and correct the shape size of the profile, and then we are getting our required product. That means assembly is a product, and you can say is a product where the more than one parts are made together in appropriate manner, that we can say that total is a product, and you can say assembly parts. Okay, to made together in appropriate manner, after that we can say that one is a assembly, or you can say as a product. More than one components, more than one parts, you can say. And what will be the approaching? The approaching is the main thing and the basic thing. We have to make our components with proper shape size, then we can maintain the assembly, then we can make the assembly easily. Here is required, likewise the sketch constraints are required to assemble the parts. Constraint, the constraint is uh, to restricting the degrees of freedom, to restricting the degrees of freedom. And as you know, constraint and the degrees of freedoms in 3D, there is a 6 degrees of freedom, isn't it? 3 will be the uh, rotational, and 3 will be translational. That 6 degrees of freedom we have to restrict, so that we can maintain the exact given shape size of the profile, so that we can maintain the assembly in appropriate manner. Okay, next. Then after that, we should know about how to enter into the sketch and how to enter into the part product. Okay, so just remember this one. Then I will show you in a software part the how to enter into the assembly workbench. First of all, we have to go the start menu, mechanical design, assembly design. Okay, this process: start menu, mechanical design, then assembly design. Then after enter into the assembly design workbench, then some toolbars is required: product structure toolbar, constraint toolbar, move toolbar. Okay, so inside there are lots of features are available, which will be which will be helpful to make our component easier. Okay, so this will be the requirement for the assembly. And the why should we use the assembly? Why should we use the assembly? Customize Customizability of orders. Customizability of orders. That means it is a manufacturing process in which the production of an item, and you can say components, begins only after a confirmed customer order is received. So that how customize, if someone, and suppose you are in the company, and one of the customer uh, said that, mm, as per the customer requirement and as per the customer need, we have to modify some basics components to modify it, customize the given data based on the customer. Then we are customize. After customize, we have to deliver within time period, and within time period is not sufficient, and that quantity also we have to maintain. That thing is very important, because when you are in company, let's suppose Coca-Cola company, okay, not specify any of the branded company, so you can take suppose, I'll just taking only for the example purpose, uh, that company is selling saying that it's required 100 of bottles, and if it is required the 100 of bottles customize, they and their requirement is to customize the bottle's shape, because nowadays it's uh, same bottle shape is there, but they their requirement nowadays, we need to change the bottle shape size based on the requirement. Then you have to customize. Then is that customization is not sufficient, someone said that and you are customized, no, that one not sufficient, and that not a sufficient data to get the required data, to get the required product. After that you have to make that profile with the help of softwares. Then after using the software, then we have to customize with the lots of process, we have to going under the lots of process inside the manufacturing unit. Then we are getting some molding, and that molding we have to show in our customer, is it your requirement, and is it required any modification, that molding components or any other demo component, is it required to modify? If customer saying that no, it's our requirement, no need to change, then we can going for the further procedure, that will be making a quantity the 100 numbers of uh, bottle. So we are proceeding the 100 number of bottle we are manufacturing. Then this will be the process we are following under the company. So these things are required, and inside the bottle is required, that cap is required, that cap and bottle both are assembly component, and cap and thread both should be equally, otherwise your liquid will be uh, leak. Okay, so that things also required, whether we are going to assemble some manufacturing, that shape size we have to maintain. Then so that we can delivery on time with the customization and to make to order. Okay, so these things are very important using the assembly, because somewhere dimension is not maintained, somewhere the shape size is not maintained, somewhere some difficulties and some parts are there. So these things we have to recognize, and inside that we have to, apart from that, we have to uh, observe that your product should not be rejected. Okay, we have to be careful at that time, manufacturing time. So that's why it's required using the assembly. And so next we are going for the kinds of assembly. We just know about we have to uh, made the components, that one is a assembly, but that one is a two types of assemblies are there. One is a top down assembly, another is a bottom up assembly. Inside the top down assembly, parts are created inside assembly workbench and assembled subsequent sequentially using constraint as per the requirement. We inside the top down assembly we are taking a base component, and based on the base component we are making rest of the and the next sequence part we have to make. Then we are giving some constraint as per the joints as per the requirement. That one is a top down assembly. And the bottom up assembly is that it says that parts are created individually inside part workbench, parts are in inserted inside assembly, located, oriented using the constraints as per the requirement. That means in bottom of assembly, already you are making some component, made some component uh, separately, rename it, and after that enter into the assembly workbench and then call one by one and assemble sequentially. That one is a process of bottom up assembly. In top down assembly, we are taking a base and we are making at there. But in bottom up assembly, already we are having some existing component. Then we are insert inside the assembly and give some constraints to restricting the degrees of freedom. Okay, so these kinds of assemblies are there like this way. Okay, if this is a cylinder and inside it we have to make some in bottom of assembly, we are making separate this one, this one, this one, this one. Then we are make inside it the assembly workbench we are made together in appropriate manner, in appropriate manner sequentially. Okay, so hope you are clear. So then I will jump into the software part. Any
Hello.
query? Yes.
मैम हिंदी में एक्सप्लेन कीजिए.
हिंदी में एक्सप्लेन. अच्छा, कौन सा पार्ट? कौन सा समझ नहीं आया? ओके, ब्रीफली मतलब समराइज कर लेती हूँ. जैसे कि आपका हो गया असेंबल करना है. असेंबल दैट मीन्स कोई भी दो तीन मोर देन वन कंपोनेंट्स को आप एक जगह जमा करके रख दो. आई एम सेइंग दैट together we are taking more than one components, more than one parts, you can say assembly. Okay, but that is not sufficient for the assembly. किसी पार्ट किसी भी कोई भी कंपोनेंट्स को, मोर देन वन कंपोनेंट्स को एक जगह रखने को उसको हम असेंबली नहीं कहेंगे. जब असेंबली को हम इस तरह इन रिक्वायरमेंट के हिसाब से, एंड दिस वन इज अ रिक्वायर्ड प्रोडक्ट, एंड यहाँ पे पार्ट वहाँ पे यहाँ पे आया है, देन सेकेंड पार्ट, थर्ड पार्ट, फोर्थ पार्ट, दैट डिपेंड्स अपॉन द रिक्वायरमेंट. अगर रिक्वायरमेंट के हिसाब से आप उसको एक के बारी दूसरा, दिन
हेलो
तीसरा, दिन फोर्थ.
हेलो मैम.
यस
हेलो हेलो
यस यस.
मैम यू डोंट.
हेलो.
मैम इंग्लिश में टेल मैम. एक्सप्लेन मैम.
Okay, I'm saying same
Students,
thing.
1 minute, ma'am. Sorry for interrupting. Actually, ma'am is telling you in both languages. Please be patient. Ma'am is telling in English and ma'am is telling in Hindi also. So be patient and don't disturb ma'am. Okay, students. And if you have anything to say that in the chat box. Don't interrupt ma'am. Please, ma'am, continue.
Okay, thank you. Okay, so the thing is we have to assemble, and that assemble, for the assemble some processes is required inside the company, inside the industry, that some process we have to follow. And inside the manufacturing, lots of process are there, we have to follow that. And the thing is we have to assemble the components and in appropriate manner with sequentially, one, then second, and then third, then fourth, then fifth. That depend upon the number of parts. Then after assemble, uh, then we are going getting our required product. If your product is not accurate shape, your assembly is not giving the accurate product based on the customer requirement. That thing is depend. So now all whole our thing is not described in here in within our time period. So I'll just uh, summarize the things. What is the requirement of the assembly, and what will be the process? What will happen if we are not uh, following the process? We are not, at last the requirement is customer requirement, making our product assemble together. Okay, so we are seeing that here, uh, bottom up assembly. Okay, so now I'll just jumping into the software part. I will show you there how to assemble the product, and if the assembly, then we'll going for the small kinematics. Okay, is it visible my screen?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, so now this is my name is nut. Okay, so now this is my nut which is created earlier, and then I'll just open my new, then is a, okay, another. Okay, this is my bolt one, as you can see. Okay, so I'm saying that in bottom up assembly, already you have some existing component, then you have to insert in assembly workbench. Okay, then now I'm just going to assembly workbench to insert that nut and bolt. Okay, so what will be the process? Just go for the start menu, mechanical design, and here is the option is the assembly design. Okay, simple, start menu, mechanical design, and then go to assembly design, and just select the assembly design. Okay, and now this environment and this interface is your product. You can say see here, this one is a product environment. That means you are in assembly workbench, and in assembly workbench, constraint toolbar, move toolbar, product structure toolbar is here. Okay, so we are going to bottom up assembly. So let me edit this one. Right click, properties, bottom up assembly. Okay, so inside bottom up assembly, already we are having existing component, we have to insert here. So how to insert? First of all, we have to click our product. Okay, we have to insert here. Is there anything? No. So we have to insert, just go for the insert menu here, or else you can take it from here. I'll just going for the insert menu. We have to insert which one? Existing component. Existing component. So let me click over here, existing component. Okay, so let me choose first one, and now as you can see, is this your component? Yes, this is my nut. Okay, so first of all, and then we have to insert the nut also. So again you have to click the product, then go to the insert menu, and then go to the existing component. So which is defined, both thing are same, but here it is renamed as a nut. Okay, now as you can see, where is my nut? This is my nut, this is my bolt, both are overlapped to each other, isn't it? It's not my requirement. Okay, so we have to manipulate. So inside the move toolbar, we are going for the manipulation option, and here is the option is a manipulation to restricting the degrees of freedom. So we are just taking here z axis. So this is my z axis. Whenever I'm going through this one, and only I'm just able to manipulate only along the z axis, along the z axis. Okay, so it's not required any over anywhere. So only this much is required. That's it, and okay, done. But still we have to restrict any of the component that will be as a base component. So we can take this one as a base component. So here is the option is a fixed component inside the constraint toolbar. So just select the fix option from the constraint toolbar and select and just click over the uh, bolt. Just click over here, and now this is my base one, because I'm just taking this one as a base, and this will be the movable component. Okay, so then we have to restrict the degrees of freedom. So here is the option is a coincidence constraint. So I'll just giving this one is a cylindrical part, and also this one is inside the profile is cylindrical part. So I'll just giving both will be coaxial. Okay, just click this one, and whenever I just clicking over the surface, it will be highlighting a axis. So that axis, and let me zoom in here, and it's highlighted the not axis. So let's click over here, and now as you can see, both are coincidence, both axial are coaxial. Okay, then, and where, and also required this gap, and this knot should be over here. So I can take a offset constraint. Here is an option. I can take the distance here. So just take a offset distance from where I can take from here to here. Select over here, and let me define the distance between them. I can take this one as a 16. Okay, it has given 16, but still is same distance. So here is the option. Uh, you can update and just click over here, and now as you can see, both are assembled together. How we know is it perfect assemble or not? So we have to use the virtually uh, giving some kinematics. The kinematics is we have to give some motions, relations, acceleration. So we have to give over here. Okay, let me check is it perfect assemble or not. Before that, going to kinematics, so let's check it using the manipulation. All the degrees of freedoms are restricted or not. Just check it. Go for the z axis. No, it's not movable. I'm just clicking over here. No, it's not movable. Let me y axis. No, it's not movable. Let me x axis. Drag it. No, it's not movable. X axis, it's a rotating. Drag around x axis. So no, it's not working. Y axis, no. Only it will be working on a z axis. Now as you can see, is it movable? So is this is our requirement. Only this should be movable. When I'm taking this one, it's not movable because this one is a uh, fixed component. Okay, so now my degrees of freedoms are restricted. Done. Then let me check using the uh, kinematics. So just go for the kinematics, and here go for the start menu, digital mockup, and here is option is a you can check it virtually. Is it how does it works, and DMU kinematics. Okay, so this kind of interface will be appear, and inside the interface the same. Here we are having a two toolbars. One is a genetic animation, and another is a dynamic kinematics. Okay, so same thing. So let me hide the previous assemble constraint. Done. Then, so here is option is a fixed part. I'll just taking a fixed part, and now as you can see there is nothing. Whenever I'm going to new mechanism, okay, you can use the nut and bolt. Nut and bolt assembly, and just go for okay. Okay, this is my nut and bolt assembly, and just click over the fixed component. Then now as you can see, if you expand, there is a mechanism, as you can see. Here is a nut and bolt mechanism. I'm saying that to restricting the degrees of freedom. Now, as you can see, DOF stands for degrees of freedom. And now, as you can see, my degrees of freedoms are 0. My degrees of freedoms are 0. Okay, that means it's constraint. Okay, so here I'll just going to take to kinematics. Is it working or not? Is it perfectly assembled or not? And how does it works? Let me check. Just go for the simulation. And which one? It's a nut and bolt assembly, isn't it? And just go for okay. Okay, so this kind box will be appear, but so let me check again. Go for here. Okay, so here I wants to check it. Go for the simulation. Okay, should be appear two boxes, but here no. Okay, it's not appear here. So let me save it first. Save it first assembly. Then we will try the kinematics. Okay. So just go to here assembly design and give it Control S. Go to desktop. Okay, now it has been saved. Okay, let me using us just go for DMU kinematics. Okay, again, is it given? Yes. Again, select over here. Okay, no, it's not appear. Okay, I'll just closing this one. Okay, again open it. Okay, let me apply again. Again, we have to go for the new mechanism. Okay, let's go for the mechanism one and select this should be the fixed component. Done. Then, okay, one thing we are missing, still we are not giving the any of the relation. already we are restricting the degrees of freedom with the help of assembly. We have to check here, is it working or not, and how does it works. Okay, so we have to give some uh, joints, and here if you expand, and lots of joints are available, for this one it's required one of the screw joint. So we have to provide the screw joint first, then we are getting the another product. We can give the simulation, and same way we have to give the line one, give some coaxially, same process, go for here. Okay, now it has been taken, and also we have to take care, but still it's not, we can't get the excess of the nut. So let me hide this one, and now it's highlighted, so you can take it. Done. Then you can uncheck the height. Okay, done. Both components has been shown, and both are coincidence. Okay, both true lines. And here we have to define the length of it. We have to rotate, and rotate from here to here, so that I'll just giving the length only it will be travel the length, and give the length, and the pitch is from where up to this 16. So I can give the 16 of the pitch, and just go for okay. And after that it will be giving your simulation is completed, and the mechanism can be simulated. Now you can apply the simulated. Before that you are not giving the simulation, so this process is very important. Still, before appearing this pop-up box, you can't apply the simulation. So this pop-up box should be appear, after that you can apply the simulation. Okay, done. And now as you can see, my restricting degrees of freedoms are 0. Now it has been simulated, you can able to simulate. So let me go for the simulation. Now as you can see, which one, this is my mechanism one, just go for okay. And now this kinematic simulation box is very important, where we can define. Okay. Mm, okay. So as you can see, here is a command, and we have to set our limitation. Now as you can see, whenever I'm moving, now as you can see how it's, how does it works, just like up to down. But it's not our requirement. Only it should be movable up to here, not out of here, isn't it? Okay, let me define some limitation. Here I'll just taking, this should be, I'll just taking a 0, and this I'll just okay, let me check. Okay, and now as you can see, 0 means up to my limitation, up to my pitch. Okay, and now there is a no limitation, so let me define some limitation up to this. It's, let's take it 50. Highest value will be 50, and okay. And now as you can see, it's a screw mechanism. It's a screw mechanism. Okay, so we have to insert here. Just go for here, insert again. Just whenever I'm just moving, automatically it will be inserted here. And now as you can see. Okay, already inserted. So let me giving a loop. Okay, and here is a play forward. Just click over here. And now as you can see, up to my given limit, it has been rotated. Okay, let me, Okay, let me change the material, and now as you can see, hide some. Okay, now as you can see. Okay, so all over how to design and how to apply, so it's bit taking time. So within this time, how much is possible, I'll just showing all the things here. Okay, so now this is all about our about the assembly inside and using the CATIA software, how to apply the assembly, what will be the process to apply the assembly. Okay, so thank you. I hope you understand and
Yes, ma'am.
enjoy the
Thank you.
session.
Yes, ma'am.
Okay.
Yes, ma'am.